So my name is Lauren Ray, and I'm working with Loreen Tilley on this project. We're going to use Fluid Flow Fluent. From here, you're going to go to your geometry, new design modular geometry. Okay. And then we want to be able to see this. So you go to your Z-axis. You're going to do your XY plane. From here, you're going to zoom in because we're going to have super tiny lines. Then the next thing that we're going to do is we're going to go to sketching, do our first line. Put it here. Then I'm going to dimension it using general. This is V1 to be 0.018. Okay, we can zoom in a little bit. From here, we are going to do our length and distance, and we're going to do it from this point to the x-axis, the y-axis. L2 is going to be 0.01. Yep. All right, and then we're going to draw in our next dimension. Line. And we are going to do the bottom piece of this line here. Take your dimensions, general, come to this line and dimension it to be 0.018 as well for V3. Okay. Then the next thing that we're going to do is the lines, the diagonal lines. Here, and now this is the throat. The next thing that we're going to do is dimension the spacing on that vertical line. So we're going to go back to dimensions. We're going to do length to distance. And it's going to be from this point to this point on the x-axis. And L4 is going to be 0.00579 for L4. Okay. Then we're going to do the same thing to the other side from the x-axis to this point. L5 is going to be 0.00579. Okay. Then we are going to come back over here and start to draw. And we are going to take the line. And we're going to draw across. It's probably too big. Sorry. Here we are. And then the same thing for the bottom. About right there. Okay. The next thing that we're going to do is go to dimensions. It's a little hidden right here. Sometimes you got to play around with it. Do length and distance. And you're going to do it from this point to the x-axis, which this is going to be L6 at 0.02673. Enter, and you're going to do the same thing to the other side. So we are going to go to our dimensions, still on length and distance, and do it from this point to the x-axis. The same dimension as L6, but we're on L7 now, so this is also going to be changed to 0.02673. Now we're going to do another length and distance from this point to the y-axis. This is L8. L8 is going to be 0.078112. Okay. And now we're going to do it for the top half. So we're going to get our length and distance again. And we're going to do it from this point to the y-axis. L9 is the same as L8. So this is also going to be 0.078112. Okay. Now we're going to make our lines for here. So we're going to draw. We're going to go to line. And we're going to go from here to here. Down. Okay. Right. So we are good with our dimensions. But we have to go to concept, surface from sketches. And then we have to hit this little mouse, go to box select, draw your box around the figure, make sure you hit apply, and then also generate. So there's one little mess up point here, which is fine. We'll go to sketching. And we're going to go to dimensions and length and distance. And we're going to dimension these 2 points to be 0. So this is L10, this is going to be 0, and this will put them together. Okay, we paused it. Okay, so we just went ahead and reconnected these lines by just simply deleting it and then drawing a new line and going through our same process. And when we did that, we were able to generate it. Now we can go on to our mesh, which is in the workbench. So we're going to go to workbench. I'm going to say mesh. And wait for it to load. All right, so I'm going to give it another second. Looks like it's still loading. Okay, now go to your z-axis. And from here, we're going to start naming our sections. So you're going to hit Control. You can do this for the inlet. Then you're going to hit right click and hit Create Name Selection. You can name it anything inner. We're just going to call it inner for simplicity's sakes. Hit OK. Do the same thing for your outer. Right click. You're going to hit create name selection again. This is going to be your outlet. Okay. And then you're going to have your walls, which you're going to hit control and click all your walls until you got all of them selected. Right click. And you're going to hit create name selection. These are going to be walls. And hit OK. And now you have your inlet over here, your outlet, and your walls all named. From there, we are going to go to mesh. And then from mesh, we're going to hit insert. From insert, we go to method. So geometry needs to change. And from there, we're going to hit apply. Now you're going to change your method. It's going to be triangles. And then we're going to generate. Okay. Now we go back to mesh. And then we're going to change this element size. This element size is going to be 0.0002. Hit enter. Generate. We're still at 5% mesh, but it does take a little while to charge, to load. Okay, so now that it has fully gone through, we can zoom in and we can see that we have a very nice mesh. Okay, now Loreen will go ahead and explain the next section.
Okay, so from the mesh, we're going to go back to Workbench and we're going to open up our setup. It's going to depend on how many solver processes your machine has. I'm going to do 3 for mine and start up the solution. Okay, and it does not seem like Fluent opened up correctly, so I'm going to go ahead and try this again. This happens to you, just close out of Fluent and try to open it again. Oh, okay. Now going back, we can see that we forgot to click update on the mesh, and that was probably why we weren't seeing the mesh when we opened up Fluent. So we're going to let that update first. Okay, now that it's done, now let's go into setup. Still going to use 3 solver processes and start the process. Fluent loads very slowly for me, so we just sometimes have to give it time. But now you can see that our geometry did mesh. It seems like they didn't like our use of naming as that for inner, so we can likely go ahead and change it. We're gonna have to go back to mesh and go into name selections. And we will rename this inlet. Back to workbench. Update this. Now we can refresh this. Okay, now that I have changed this to say that this is the inlet, it is reading that this is the inlet, that's the outlet, and we can see our flow. So we're going to start in general. We're going to choose a density base solver. From there, we're going to go into models. We're going to turn energy equation on. We're going to go into viscous. We're going to make it inviscid. We're going to go to materials next. We're going to go to fluid, air. Here, we're going to change density to be ideal gas. Change create. And we're going to close this out. After that, we're going to go on to our boundary conditions. We're going to click on the inlet. Okay, for the inlet, we actually want to change it to pressure. So we're going to double click on boundary conditions here so we can click inlet and we can change it to a pressure inlet. From here, we can make our total pressure 12.41 megapascals. And then our initial pressure is going to be 1,000,000 pascals. Okay. We're then going to click on thermal, and we're going to make our total temperature 3,400 Kelvin. We're going to click apply and close. Next, we can move on to our pressure outlet. We're going to edit that. We're going to change our gauge pressure to be 58024.3. We're going to change our thermal to be 1390.33. Click apply. Close. We're going to make sure that our walls are indeed walls and that our interior surface body is actually an interior surface. After that, we can go to initialization. We're going to want hybrid initialization, but we're going to want to change the settings to do 24 iterations. Apply. And now let's initialize. Okay, now that our hybrid initialization is done, we're going to go into run calculation. We're going to change our number of iterations to 1,500. And we are going to click calculate. I'm going to stop the recording just because it's going to take a bit of time. Once it's done, I'll hop back on. Okay, now it has finished completing its calculations. So I'm going to start off by creating our contours. I'm going to go down here to results, graphics, contours. I'm going to start off with our velocity one. So we're going to do velocity. I'm going to change this to velocity magnitude. I'm going to click our interior surface body and save display. We can then see that that is our magnitude of velocity throughout the nozzle. That looks pretty good. We can see some nice expansion waves. I can then change this to get our pressure. There, we're going to click pressure. It gives us static pressure. We can save display. And now you see the contours of our static pressure. The next one that we need is density. So we'll go here, down to density, save display. That's what our density looks like throughout the nozzle. Still looks pretty good. We got some nice expansion waves. This is going to be a little bit repetitive. Next one is speed of sound. That one's a little bit harder to find. We're going to go into properties and click sound speed, save display. And there's our speed of sound. Next, we're going to do temperature. So temperature, static temperature, save display. And that's contour of our stack temperature. The last contour we need is Mach number. So we're going to go into velocity. And then we're going to choose Mach number. Save display. And that will give us our contours of the Mach number. Next, we're going to need to create some plots. So we're going to go down here to plots, XY plot, double click it. And we're going to be able to say our Y function, which will start with the first one. We want velocity plus magnitude. We're going to choose a direction vector. For this case, I made a center line that goes down the center line of my nozzle. It's going to depend, where your center line is going to depend on how you position your nozzle in your origin. So just create a center line that goes through the nozzle, and we'll be able to save the plot. We can now see our plot for the velocity magnitude. In order to get the values of this table, we would want to write to file and click write, and then it's going to save as an Excel file. Now we're going to move on to get the rest of our charts. So we're going to go with pressure. I'm going to unclick write because I don't need to write all these files. I already have them. Click save plot. We get our static pressure plot. That looks pretty good as well. Move along just like we did for the contours. We're going to do them all over again. So density, save plot. Looks good. Next one is speed of sound. So again, properties, sound speed. Make sure our direction vector is still the center line. I'm going to save and plot that. Next is temperature. Save and plot. There's a temperature throughout the nozzle. Lastly, we have Mach number, so velocity, Mach number, save and plot. Okay, and that is all of the plots that we need to do. Just make sure to write to file and write them in order to get all the values that you need.